Hello friends, welcome to engineering tutorial. So this is the 9th question related to maximum power transfer theorem which we are going to discuss. So here we have this circuit, typical bridge circuit, and here we have been asked to find the value of this resistor R such that maximum power transfer happens to it, and the value of that particular resistance value for which maximum power transfer happens. So the usual Thevenin theorem approach we will go through that way, first finding VTH, then RTH, and then finding the maximum power transfer value. So first we have to find VTH across these two terminals by removing this resistor. So we have to redraw the circuit. So it will be something like this. Okay, this is open circuited, and this is the voltage connection, 60 volt. This is 10 ohm, this is 25 ohm, this is 20 ohm, this is 5 ohm. Now we have to find VTH. So for that we have to find the current flowing through these resistors. So this is I1, this is I2. The same current I1 will flow through this 20 ohm resistor, and the same current I2 will flow through this 5 ohm resistor. So this will be like, we'll have to apply the KVL equation. So it will be 60 minus 10 I1. So this is the polarity, okay, plus minus, here also it is plus minus and plus minus. So it is 60 minus 10 I1 minus 20 I1 is equal to 0. That implies 60 minus 30 I1 is equal to 0. That implies I1 is equal to 60 by 30, which is equal to 2 ampere. So I1 is equal to 2 ampere. This is one equation. Next we will apply KVL in this path like this. Okay, here we applied it like this, here we will apply it like this. 60 minus 25 I2 minus 5 I2 is equal to 0. That implies 60 minus 30 I2 is equal to 0. That implies here also I2 is equal to 60 by 30, 2 ampere. So I2 is equal to 2 ampere. This is the second equation. I1 is equal to 2 ampere and I2 is also equal to 2 ampere. Now we have got I1 and I2. Now we will apply KVL in this path from VTH like this, okay, like this, to find the value of VTH. So here when we apply KVL in that way, we will get VTH plus 10 I1. Why plus 10 I1? Because we are moving from minus to plus. VTH plus 10 I1 minus, because from plus to minus we are moving, minus 25 I2 is equal to 0. So I have already discussed about the different ways in which we can apply KVL. the voltage polarities across resistor, inductor, capacitor, everything related to that I have discussed. So please watch the introductory videos on the circuit theory playlist. So VTH plus 10 I1 minus 25 I2 is equal to 0. That implies, substituting the values of I1 and I2, VTH plus 10 I1, which is 2, minus 25 into 2 is equal to 0. That implies VTH plus 20 minus 50 is equal to 0, and implies VTH is equal to 30 volt. VTH is equal to 30 volt. So we have got VTH. Now we have to find RTH. So we have calculated the value of VTH, 30 volt. Now we have to find RTH across the same two terminals. For that we have to deactivate this voltage source, independent voltage source. We have to short circuit it. So the circuit will look something like this. Okay. Ten ohm, 25 ohm, 5 ohm, 20 ohm. You have to find RTH here. So if you notice, if we try to redraw this circuit to simplify it, it will look something like this. Ohm, 5 ohm. This would be RTH. So it will be, RTH will be 10 parallel 20 plus 25 parallel 5. So it will be 10 into 20 by 10 plus 20 equal 25 into 5 by, this is plus 5 by 25 plus 5. So it will be, let us calculate, it is 200 by 30 plus 25 into 5 by 30. Okay. So the result is coming around 10.83 ohms. 10.83 ohms RTH. So as per the statement of maximum power transfer theorem, maximum power is transferred to the load resistor if its value is equal to the internal resistance, the Thevenin resistance. So in this case, the Thevenin voltage is 30 volt. The Thevenin resistance is equal to 10.83 ohm. So maximum power will be transferred to the resistor R if its value will be equal to 10.83 ohms. Okay, 10.83 ohms, and that maximum power PR max will be equal to VTH square by 4 RTH, which is equal to 30 square by 4 into 10.83 ohm, 4.10 to 83. Let us calculate that. It will be 900 divided by 4 into 10.83, which is equal to 20.775 watts or 20.78 watts. Okay, PR max. PR max is equal to 20.775 watts. Okay, this. So here is the 9th question related to maximum power transfer theorem. Okay, so we have calculated VTH, we calculated RTH is equal to 10.83 ohm, and then PR max is equal to VTH square by 4 RTH, which is equal to 20.775 watts. Okay, so I hope you like this videos related to maximum power transfer theorem. So please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.